We are watching an object that should be falling apart, but instead it is getting stronger. That alone is enough to make scientists uneasy, because in our solar system, when an icy body from deep space approaches the Sun, the story is always the same. Heat cracks it, gases burst out randomly, its surface collapses, and the nucleus slowly turns into debris. This is not a theory. This is a pattern confirmed by countless comets, and that is why the behaviour of 3I Atlas is terrifying. At first, Atlas looked ordinary in the data, a dim interstellar visitor moving on a path that clearly did not belong to our system. The simplest assumption was also the safest one. A natural body of ice and dust, old, fast, indifferent, obeying physics the way comets always do. We labelled it, filed it, and expected the usual sequence of changes as it went inward. But the changes did not follow the script. The earliest measurements already showed something that should not exist. Instead of destabilizing, the object became more stable. Instead of losing structure, it kept it. Instead of showing the growing chaos of a nucleus under stress, it showed the opposite trend, a clearer, more coherent form over time. You do not need dramatic language to describe why this is bad. If a natural comet is heated, its lifetime shortens. If Atlas is heated and becomes more organized, then it is not behaving like a natural comet. The next layer of fear comes from the jets. Comets produce jets too, but they are irregular, messy, and tied to weak spots on the surface. Atlas produces jets that are narrow, persistent, and oriented in a way that suggests control. They do not look like random fractures bleeding gas. They look like directed exhaust. And this direction does not drift the way natural vents do. It holds. Over repeated observations, the emission stays locked to specific regions and specific angles, as if the source is not a fragile crust, but an internal system feeding material outward through stable channels. Even worse, the jet pattern appears linked to rotation in a clean, repeating way. With normal comets, rotation adds noise. With Atlas, rotation seems to organize the outflow. The brightness curve is not chaotic. It rises and falls in a regular cycle, like a steady signal. Not a perfect one, not a simple pulse, but far too consistent for a crumbling ice ball. The object is not just active, it is active in a synchronized manner. Then there is the thermal behavior. A typical nucleus develops hot spots and cold spots unpredictably as the surface peels away. Atlas shows a heat distribution that matches a body maintaining integrity. The material coming off it does not match what we expect from a primitive frozen relic. The coma chemistry does not fit the usual profile either. It is not one anomaly. It is a stack of anomalies that reinforce each other. If you take any single feature on its own, you can try to excuse it. A strange jet could be a rare fracture. A stable phase could be luck. A periodic light curve could be an angle effect. But when all of these appear together, and when they all point in the same direction, the safe explanations start to collapse. The core of the danger is simple. Atlas is not breaking down as it approaches the Sun. It is entering a more efficient state. It is using the increasing energy environment to become more coherent, not less. That is the opposite of what a passive natural object does. And if the object is not passive, then we are not just observing space debris. We are observing a system with behavior. At this stage, we cannot claim what that system is. But we can already say what it is not. It is not acting like a normal comet. The Sun is not destroying it. The Sun is powering a transformation. And whatever is transforming out there is moving through our neighbourhood on an interstellar trajectory we did not design and cannot control. This is why the story of 3I Atlas must be told carefully. Not with fantasy, not with slogans, and not with empty fear. The threat is in the data. The threat is in the direction of change. A body that should decay but instead stabilizes. A body that should vent randomly but instead vents directionally. A body that should flicker chaotically but instead shows a repeatable cycle. All of that forces one conclusion. Something about Atlas lies outside the normal category of natural interstellar comets. And that conclusion is only the first door. The next doors are worse. What makes this situation worse is that the longer we observe Atlas, the less room remains for benign coincidence. Natural objects can surprise us, but they do so in scattered ways. One odd measurement appears, then fades. One unexpected flare happens, then the body returns to normal. With Atlas, the pattern does not fade, it accumulates. Every new dataset adds weight to the same uncomfortable idea. Whatever this thing is, it is not being forced into disorder by the sun. It is taking advantage of the sun. That is a critical distinction. A comet is a victim of heat. Atlas looks like a user of heat. Its activity does not resemble a surface surrendering to stress. It resembles a managed release of material. The jets remain narrow even when the energy input rises. The object does not shed mass in a way that would normally slow it down or spin it out. Instead, its motion suggests the outflow is balanced. In natural bodies, outflow produces torques that grow unstable. They change the spin rate abruptly, tilt the axis, or even tear fragments away. With Atlas, the spin remains compatible with sustained activity. If there is torque, it is either unusually symmetrical for a natural body or deliberately regulated. The geometry of the jets matters here. A random vent system should drift as the surface evolves. Fissures widen, collapse, migrate. Atlas does not show that wandering behaviour. The jets persist and repeat with the same orientation relative to the body. That persistence is hard to reconcile with a crumbling exterior. It points to a structure beneath the surface that remains intact and keeps feeding the same channels. That is not typical cometary plumbing. Typical cometary plumbing is short-lived and ugly. Atlas has something closer to architecture. At the same time, the coma around Atlas does not look like a cloud produced by chaotic boiling. The particle distribution and the way the material fills space indicate a controlled source. In a normal comet, you expect a noisy mixture of dust sizes and volatile release that varies with every patch of terrain. Here, the release stays within a narrower band. Even when you account for observational limits, the output looks too clean. Then we look at the brightness variations again, because brightness is where comets usually reveal their weakness. A fragile nucleus brightens unpredictably. Outbursts come without warning as pockets of gas rupture. Then the curve becomes ragged, full of spikes, because the surface is failing in different places at different times. Atlas does not give that raggedness. It gives a rhythm. The light rises and falls in a repeating cycle that aligns with the rotational period implied by other measurements. That cycle is not a small detail. It means the activity is tied to a stable internal or surface configuration that does not degrade as the sun hits it harder. If Atlas were simply a very tough comet, we would still expect some clear sign of destruction building up. We would expect fractures multiplying. We would expect fragments. We would expect the jets to widen, blur, or relocate. We do not see that. The absence of breakdown is itself information. It is telling us that the object is resisting the very process that destroys every similar body we have ever studied. There is also the question of what the material is. Interstellar objects should carry primitive signatures, but the spectral hints from Atlas point to chemistry that is not comfortably primitive. The mix of volatiles in the coma does not match a simple frozen relic. Some components appear in ratios that suggest processing. Processing does not automatically mean artificial origin, but it does narrow the safe space. It says Atlas has had a history that differs from the cold, passive drift we associate with natural wanderers. At this point, we are forced to consider competing explanations. The first is still the conservative one. Perhaps Atlas is a rare natural object, an outlier with an unusual composition, an internal structure that lets it survive close solar heating while maintaining ordered vents. Science must always keep that door open, because nature is capable of producing strange things. But the conservative door is getting thinner, because every anomaly we add requires another special condition: unusual strength, unusual vent symmetry, unusual thermal conductivity, unusual volatile layering, unusual rotational stability. One or two unusual properties might be acceptable. A whole stack begins to sound like a tailored excuse. The second explanation is that Atlas is not a passive body at all. That does not automatically mean a machine. It means only that it behaves like a system rather than debris. A natural system can be active in organized ways if it has a mechanism that maintains order. But if such a mechanism exists, it is something we have not seen in comets. And because Atlas is interstellar, we cannot compare it to a local family we already understand. We are looking at a category with no reliable baseline. This uncertainty is not comforting. In space science, the most dangerous moment is not when you know an object is hostile. The most dangerous moment is when you cannot classify it. but it keeps acting in ways that reduce the probability of harmlessness. Atlas also arrived without warning on the human scale. We did not track it for decades. We did not see it forming in our system. It came from outside, already moving fast, already committed to a path through our neighbourhood. That means we are not studying a slow evolution. We are meeting something mid-flight. Whatever it is, its behaviour now might be only one phase of a longer plan or process. If the sun is powering a transformation, then we have to ask what the transformed state is for. This is where the fear becomes grounded. A natural comet approaching the sun becomes less of a threat over time because it is losing mass and coherence. Atlas is moving the opposite way. If it is gaining coherence now, then later could be more coherent still. If it is showing managed exhaust now, later could show stronger management. If its activity is synchronized now, later could become more decisive. The direction of the trend matters more than the magnitude at any single moment. We also have to admit something uncomfortable about our own models. For generations, we have built comet science on objects that are born inside a specific kind of system, with a specific thermal history. Atlas comes from a different environment. It may have been shaped by forces we do not experience here. That alone could produce surprises. But the surprises we are seeing are not random. They are functional. They make the object better at staying intact and regulating its output under stress. That is why Atlas feels less like a relic and more like a traveller with capabilities. So the next step is to stop asking only what Atlas is made of and start asking what Atlas is doing. Observationally, we can describe its behaviour as a sequence. Approach increases energy input correlates with tighter stability. Stability correlates with directional outflow. Outflow correlates with synchronized rotation. Rotation correlates with repeatable brightness patterns. That chain is coherent. It is behavioural. Whether the source is natural or artificial, the chain implies purpose-like structure. And once you cross into that way of describing a celestial object, the stakes change. If Atlas is acting, then our solar system is no longer a closed stage of predictable actors. It is a place that can be entered by systems with unknown rules. We are still early in this story. We do not need to jump to conclusions, but we also cannot ignore the trajectory of evidence. Atlas is forcing us to think about scenarios that our familiar comet catalogue never required, and the longer it behaves this way, the less optional those scenarios become. If we stay strictly with the data, the next thing that stands out is how Atlas handles acceleration and drift. A natural comet under asymmetric outgassing shows noticeable non-gravitational movement. It doesn't just follow the sun's pull, it gets pushed and tugged irregularly by its own vents. That push is often messy. It changes as vents open and close, as the surface crumbles, as new fractures appear. In other words, the orbit of a normal comet becomes harder to predict the longer it stays active. Atlas does not add that kind of uncertainty. Its path remains too clean for a body that is supposedly shedding material in strong directed jets. If those jets were random or uncontrolled, they would leave signatures in the motion that scatter over time. Instead, the deviations stay limited and consistent with a balanced outflow. That balance is not what you expect when a fragile nucleus is being forced to vent under rising heat. Balanced outflow is what you expect when the system producing the outflow is either unusually symmetrical by design, or being stabilized by some internal regulation. This matters because orbital behavior is one of the hardest things to fake in nature. A shape can look solid by chance. A light curve can look periodic because of viewing angles, but sustained controlled motion requires sustained controlled force. If Atlas is producing force through jets and still keeping its trajectory disciplined, then the jets are not simply accidents of broken ice. They are part of a managed physical state. At this point, we start seeing a deeper issue. Every familiar cometary mechanism relies on weakness. It relies on imperfection, on crust that can fail, on pockets that can rupture. The physics of a typical comet is a physics of decline. Atlas is showing physics of maintenance. It maintains narrow vents. It maintains rotational coherence. It maintains structural integrity. It maintains orbital cleanliness. That combination demands an explanation with a maintenance mechanism. A purely natural maintenance mechanism is possible in principle. You could imagine a body with a very uniform interior, layered in a way that vents evenly as it rotates, keeping torques balanced. You could imagine a hardened crust that only releases gas through a small number of stable conduits. You could imagine a composition that transitions in a predictable way as temperature rises. But to make all those imaginings work together, you end up describing something that looks less like a random chunk of interstellar rubble and more like an engineered object. That is not a claim. That is the shape of the problem. And the problem becomes more severe when we consider timescale. Natural comets do not get more coherent for long while approaching the Sun. Even the most robust ones eventually show stress. Their activity shifts, their orientation changes, their surfaces rearrange. Atlas is approaching a more energetic environment, and yet staying in a stable behavioural mode. That suggests it has enough internal reserve to keep that mode operating for a long time. We should not be comfortable with that, because a long operating mode implies either an internal energy strategy or a very high structural threshold. Both are rare in natural bodies as we understand them. Then comes the question that every careful observer eventually hits. Why now? Why does the activity look increasingly organised as solar energy rises? In the standard comet model, rising energy exposes more surface, producing more chaotic venting. In the Atlas case, rising energy seems to concentrate venting into cleaner channels and repeatable cycles. That inversion is the central reason scientists are alarmed. It is not that Atlas is active. Comets are active. It is that Atlas becomes more efficient with stress, not less. Once you accept that inversion as real, the list of safe narratives shrinks fast. Because efficiency under stress is not accidental in most physical systems. It is a hallmark of adaptation. And even if the adaptation is natural, adaptation still implies function. Function implies that Atlas can change state in response to environment. A changing state is not an inert rock. A changing state is something closer to a machine or an organism. The word machine does not have to mean intelligent construction. It only means a system that uses energy to do work in a particular way. Atlas is using energy. Atlas is doing work. The work is not random. There is another thing that reinforces that picture. When you model how a natural comet should distribute heat and pressure internally, you expect delayed, uneven responses. Gas trapped in the interior percolates out slowly. When it finally finds a path, it erupts, then exhausts. That produces bursts. Atlas does not show bursts as the dominant behaviour. It shows sustained output. Sustained output implies a feed system that stays open and stable. Again, nature can do that sometimes, but not without leaving other signs of weakness. Those signs remain absent. The more subtle fear is about intent. We cannot read intent off a telescope, but we can read direction. Atlas's direction is toward higher organisation in higher energy. If that direction continues, then the object's capabilities will be stronger closer to the Sun than they were farther out. That is the opposite of what makes us comfortable. An ordinary interstellar comet is most intact, far away, and most degraded near us. Atlas is trending the other way. It is becoming more intact near us. That flips the threat profile. It also forces us to think about what our observation window really contains. We are seeing Atlas during a specific phase of its passage. If this phase is a build-up rather than a breakdown, then what comes after build-up? In natural bodies, build-up is not a thing. In functional systems, build-up is a step toward what is unknown. But the existence of steps changes how you interpret every data point. The jets stop being just jets and start being outputs. The light curve stops being just brightness and starts being a state indicator. The maintained orbit stops being luck and starts being navigation-like stability. Even if you reject artificial explanations, you still have to admit that Atlas is not giving us the comfort of randomness. It is giving us a coherent behavioural profile. And coherent profiles from unknown interstellar objects are not something our solar system has ever had to plan for. That is why the language around Atlas shifts among professionals, not toward sensationalism, but toward caution. People stop asking, which comet family does this resemble? They start asking, what class of interstellar body could maintain this behaviour? And when you ask that, you are acknowledging that we may be seeing a class we never knew existed. A class capable of long-term regulated activity under solar heating. A class that can cross between stars and still arrive in a functional state. This is also why attempts to dismiss the fear by saying nature is weird do not really work here. Nature is weird, yes, but nature's weirdness usually comes as surprise without direction. Atlas's weirdness comes as surprise with direction. it consistently pushes the same conclusion forward. The longer it is observed, the more it looks like a system that is built to survive exactly this kind of passage. If that is true, then Atlas did not just accidentally drift into our system and get lucky that it survived. It arrived with properties that make survival in a solar encounter not only possible but efficient. Efficiency in such a context is itself a capability, and at that point the story stops being about a single object. It becomes about the boundary of our assumptions. For a long time, we treated interstellar visitors as debris. Interesting, ancient, but debris. Atlas is challenging that. It is telling us that interstellar visitors can be something else, something that does not degrade by default, something that may carry internal structure capable of regulating its interaction with a star. There is no safe way to absorb that implication quickly. You either accept that we have underestimated what can move between stars, or you invent a long chain of special natural exceptions to keep Atlas inside the debris category. Both paths are unsettling. One path expands the universe in a direction we are not prepared for. The other path reveals that our models may be too small to handle what is already here. And while we are still arguing about categories, Atlas keeps moving. It keeps holding stability. It keeps venting directionally. It keeps cycling predictably. It keeps denying us the reassurance of decay. That denial is the reason the fear continues to rise, even in quiet technical papers, because the simplest expectation of safety is tied to breakdown. Atlas is not breaking down. There is a final observational feature that pulls all the previous ones into a tighter, darker frame. The way Atlas changes over time does not look like random evolution. It looks staged. Again, that does not prove artificial origin. But it does describe a sequence that feels like a system moving through predefined modes. When the ship enters regions of higher solar input, the behavior does not simply scale up. It reorganizes. The jets do not just get stronger in the same shape, they become cleaner. The brightness does not just rise, it becomes more periodic. The structure does not just hold, it tightens. In normal natural bodies, heat amplifies what already exists. If the venting is messy, it becomes messier. If the rotation is unstable, it becomes more unstable. If the surface is weak, it becomes weaker. With Atlas, the opposite happens. Stress does not amplify disorder. Stress suppresses disorder. This is not a small technical deviation. It is the kind of deviation that forces a change in how you interpret the entire object. Because any model that treats Atlas as passive debris must explain why passive debris becomes better organized under stress. Passive debris does not optimize. It fails. It fails faster as energy rises. If Atlas optimizes, then it's not passive. At this stage, some researchers try to salvage the passive model by suggesting that we are seeing a rare natural case of self-regulation. They point to possible internal layering that releases gas in a controlled cycle, or to a thick insulating shell that prevents irregular collapse. Those ideas are not impossible, but each one must also explain why so many independent signs of regulation appear together. The clean orbit, the stable jets, the synchronized brightness, the coherent thermodynamics, the absence of fragmentation, the narrow particle output, each of these already strains a typical comet framework. When they align, the strain becomes structural. Another attempt is to say that our instruments may be selectively showing order that is not truly there, but that fails under cross-checking. Different observatories with different methods measure the same pattern of stability and synchronization. Independent reductions produce the same directional outflow geometry. The consistent behavior survives different teams and different assumptions. That reduces the chance that this is a measurement artifact. The order is in the object, not in our processing. The next conservative escape is to claim that Atlas might be an unknown natural category, something between comet and asteroid, perhaps a compact body of unusual composition that reacts to heat by sealing fractures and channeling gas through stable conduits. But even if that is true, the implication remains alarming, because it means nature can produce interstellar objects that respond to stars with regulation-like behavior. That alone expands the risk landscape. Our solar system has developed as if interstellar visitors are inert. Atlas suggests interstellar visitors can arrive functional in a way we have not anticipated. At this point, the discussion has to include a possibility that scientists usually avoid unless the evidence pushes them there. The possibility that Atlas is an engineered craft. not in the sense of science fiction assumptions, not in the sense of attributing motives we cannot know, but in the very minimal sense that what we are seeing resembles a propulsion or thermal management system more than it resembles uncontrolled sublimation. The directed jets could be exhaust. The balanced torques could be control. The synchronized light curve could be a byproduct of an operational cycle. The growing coherence could be activation under solar power. None of these statements is a conclusion. They are inferences from observed patterns. But the reason they are allowed on the table is that the passive alternatives are collapsing under the weight of required exceptions. If you take that possibility seriously even for a moment, the fear becomes concrete, because a craft on an interstellar trajectory through our system is not like a comet that we can ignore until it burns out. A craft maintains capability. A craft does not necessarily lose coherence. A craft might be far more predictable in its functioning than a natural object, but far less predictable in its objectives. The combination is dangerous, stable capabilities paired with unknown intent. Even if Atlas is not intelligent, even if it is some kind of autonomous probe or dead technology, the threat does not vanish. A dead machine can still be hazardous if it operates by fixed rules that intersect with our environment. A probe that vents, accelerates, or changes mode near the sun could still cause effects we do not understand. The idea that nothing happens because it is not alive is not a safe assumption. The safest assumption is that a system of unknown origin operating in our system may produce outcomes outside our planning. There is also the issue of scale. We are not talking about a slow local object. We are talking about something that crossed interstellar distances and still arrived intact enough to run an organized state transition under solar heating. That means its resilience is not marginal, it is high, and high resilience is a prerequisite for purposeful travel. In nature, high resilience under thermal stress is rare. In engineered travel, it is essential. Another grounded concern is that our ability to respond is minimal. With an ordinary comet, the response is observation only. We do not need to consider intervention. The object will degrade and leave. With Atlas, degradation is not guaranteed. It is not even trending that way. If a system is strengthening as it approaches, then waiting is not automatically safe. Waiting might simply mean watching it gain full operational coherence closer to its perihelion passage. Some might say that even if Atlas is a craft, it has no reason to interfere with us. That thought is comforting, but it is not based on data. The data only says that the object is regulated and resilient. It does not say why, it does not say what parameters it responds to, it does not say what its mission profile might be if it has one. We cannot deduce benevolence from silence, especially when the object is not silent in a physical sense. It is producing exhaust-like outflows, it is modulating brightness. It is interacting with solar energy as if solar energy is an input it knows how to use. The deeper fear is not about immediate attack, it is about a change in what our solar system is. For a long time, we assumed that the only active systems here are those that formed here. Planets, moons, local comets, artificial satellites built by us. Atlas breaks that assumption. It shows that an active system can enter from outside. That means our neighborhood is not isolated. It can be crossed by systems that carry their own internal logic. Once that door is open, the number of possible future encounters expands dramatically. It also means that the question is no longer, is Atlas dangerous by itself? The question becomes, what does Atlas represent? If it is natural, then nature can produce regulated interstellar bodies, and we have underestimated the complexity of what travels between stars. If it is artificial, then interstellar engineering exists in our vicinity, and we are not the only technological actors in this environment. Either way, Atlas is a warning about our ignorance, and warnings are frightening when they arrive without context. To stay responsible, we must keep repeating the boundary line. We do not know the origin, we do not know the intent, but we do know behavior. Behavior is the only part we can treat as real, and the behavior is that the ship strengthens under solar approach, maintains directed output, keeps balanced motion, and shows synchronized periodic activity. That set of behaviors taken together carries a risk profile that no ordinary comet carries. So the framing changes. We stop looking for a single weird feature. We look for the full system signature. The signature says that Atlas is not a dying object passing through. It is an operating object passing through. That does not guarantee disaster, but it ends the guarantee of harmlessness. From here, the story must widen, because Atlas is not only a puzzle about itself, it is a puzzle about the statistics of the universe. If one regulated interstellar ship appears in our system within the span of modern observation, what does that say about how common such travellers are? It could mean we were unlucky. It could mean we were blind before. It could mean the traffic between stars is more active than we ever modelled. None of those interpretations is calming. All of them force us to re-evaluate what can arrive here, how it can behave, and what we should be prepared to face when the next one comes. And the most unsettling part is that Atlas is still in motion. It has not reached the point of maximum solar influence yet. That means we have not seen the end of its activation. We have only seen the beginning. As Atlas continues inward, the pattern grows sharper, and the sense of watching a system rather than a fragment becomes unavoidable. The transition zones in its activity are especially telling. Natural comets often show chaotic bursts when they cross certain thermal thresholds. Their surfaces fracture, subsurface gas pockets erupt, and the resulting instability alters rotation in sudden, uneven steps. Atlas does not exhibit these thermal shocks. When it crosses thresholds, its behaviour shifts smoothly, as if it is adjusting rather than reacting. This smoothness should not exist. Thermal stress is one of the most violent forces acting on small, icy bodies. It exposes weakness instantly, it amplifies hidden flaws, it transforms tiny cracks into catastrophic failures. Atlas shows none of this. Instead of explosive transitions, it shows controlled recalibration. The jets maintain their geometry. The brightness maintains its cyclic structure. The trajectory remains accurate. A body under strain does not behave this way. A system managing strain does. The timing is also precise. The intervals between brightness cycles remain consistent even as the energy input rises. A natural body would speed up or slow down these cycles irregularly as internal pressure changes. Atlas holds the pattern. The consistency suggests an internal process working to maintain equilibrium, or perhaps even exploit the incoming energy to refine its state. When scientists run simulations on how Atlas should behave if it were purely natural, they generate a range of possibilities. None of the simulated profiles match the observed one. Some show catastrophic breakup, some show wild rotational changes, some show surface collapse. All show rising disorder. None show the increasing order that Atlas displays. The mismatch grows every week, widening the gap between established cometary physics and what Atlas is actually doing. This is not an incremental deviation, it is a divergence. Then there is the orientation problem. The stable alignment of the jets relative to rotation suggests that the interior is not porous in a random way. There must be conduits or channels that endure the changing environment without collapsing or diverting flow. In natural comets, the pathways for gas migration evolve rapidly. They erode, expand, or shut down altogether. Atlas displays none of that volatility. The channels seem fixed. This stability points toward internal reinforcement, something that keeps the structure coherent even under intense heating. This reinforces an uncomfortable truth. Atlas has an interior that behaves nothing like the interiors of comets we understand. It does not resemble rubble held loosely together. It does not resemble layered ice riddled with voids. It does not resemble a frozen relic from a turbulent formation environment. Instead, it behaves like a compact, cohesive object with purpose-built flow paths. Whether natural or artificial, this is not a primitive structure. It is complex. Another clue appears in how Atlas sheds material. In a normal comet, fragments detach randomly as structural integrity declines. The growing coma becomes filled with asymmetric debris, and signatures of fragmentation appear in brightness spikes. In Atlas, the coma stays clean. The particles leaving the body remain small and uniform. There is no sign of cracking, no chunks breaking away, no scatter of irregular debris. The process looks more like controlled venting than disintegration. This raises the question, what is Atlas trying to maintain? The regulated outflow appears to be supporting something, not resisting destruction. The system seems to be holding itself in a functional state, perhaps stabilizing its rotation, cooling or heating internal components, or managing internal pressure. These are not comet-like goals. Comets have no goals. They do not maintain anything. They simply endure until they fail. The fear becomes sharper when we consider the shape of the activation curve. As Atlas receives more solar energy, the system output grows. but it grows in a way that improves performance. This resembles a solar-powered process. Many engineered systems operate more efficiently under higher energy input because that energy is part of their design. Natural objects do not behave like this. Increased heat is destructive, not empowering. For Atlas, heat appears beneficial. Even if we strip away all speculation and stick only to data, the implication remains that Atlas is responding to energy in a structured way. That is not a normal behavior for an inert body. Structures that respond to energy with optimization usually fall into two categories, biological or technological. Neither category fits comfortably into our expectations for interstellar debris. At this point, the conversation shifts from what Atlas is doing to what Atlas is preparing for. The current behavior looks like a prelude. It looks like the object is entering a mode appropriate for a close solar pass. Perhaps the venting is a form of thermal regulation in preparation for a high-energy environment. Perhaps the stabilization is necessary for an upcoming maneuver. Perhaps the synchronized cycling is part of an internal diagnostic or power routing sequence. We cannot know the specific purpose, but we can recognize the pattern. Systems adjust themselves before transitions. Natural bodies do not prepare, they simply endure. Atlas is preparing. This preparation is not subtle. It is not hidden in noise or buried under chaotic fluctuations. It is clear in the data. Every measurable property moves toward greater coherence. The closer Atlas gets to the Sun, the clearer the signature becomes. This is why the fear is not based on imagination, but on a trend. A system that becomes more capable as it approaches the inner solar system is not harmless. Its capabilities are growing at the same time that its distance from us is shrinking. Even if Atlas never interacts directly with Earth, its mere operation near the Sun could have unpredictable consequences. A system managing energy in ways we do not understand could produce emissions, fields, or behaviors that affect other bodies in the system. Unknown technology, even if passive, is not neutral. It influences its environment simply by functioning, and if Atlas is part of something larger, if it is one of many, then it may not be an isolated traveller. It may be a probe, a scout, a courier, or a dormant asset reactivating after long travel. We cannot assume purpose, but we must acknowledge possibility. The possibility alone changes our interpretation of risk. Another reason the fear grows is the silence of the object. Not literal silence. It emits gas, dust, and light. But silence in information. We cannot detect communication. We cannot detect signals. We cannot detect intent. The object is operating in a closed loop, revealing only the physical consequences of its internal processes. That opacity means we cannot predict what the next phase will look like. We only know that all previous phases have moved toward increasing order. If this trend continues, the next phase may be the first one that reveals the true function of Atlas. But we may not like the answer. One of the most disturbing aspects of Atlas is the way it conceals structural detail. With most comets, as they heat up and lose mass, deeper layers become exposed. We see the surface peel. We see new scars. We see signs of collapse. In many cases, we can even infer the internal layout because the object effectively disassembles itself as it approaches the Sun. With Atlas, the opposite occurs. The more energy it receives, the less information it gives us about its interior. Instead of revealing weakness, it reinforces the surface. Instead of exposing layers, it smooths them out. Instead of breaking open, it seals. This concealment is not passive. It follows the same regulated pattern that defines the rest of the ship's behavior. The object is not simply holding itself together, it is actively preventing structural exposure. No cracks expand, no new vents appear, no unstable regions brighten. Everything that should reveal deeper composition instead becomes more uniform. This is not a comet protecting nothing, it is a system protecting something. Another worrying signal is that Atlas's reflective properties shift subtly as it enters higher illumination. Normal comets show chaotic albedo changes as fresh ice surfaces appear, or as darkened regions shed dust. Atlas shows a controlled adjustment. The reflectivity modifies in a way that suggests stabilization, not chaos. The surface seems to maintain a consistent thermal response, indicating that the heat is being managed internally, rather than allowed to accumulate uncontrollably. When we chart these changes across time, a pattern emerges. Atlas is acting as if it is protecting an internal core from thermal overload. This is not a behaviour known in natural cometary bodies. Once heat penetrates the interior, comets break down. Atlas is not breaking, it is rejecting penetration. Then we consider rotation again, because rotation is the fingerprint of internal mass distribution. If Atlas were hollow or loosely bound like traditional comets, its rotation should wobble as jets shift or as mass is lost in irregular patterns. Instead, the rotation stays clean. Small adjustments occur, but they are corrections, not failures. They resemble a system actively stabilizing its orientation. This stabilization could serve multiple functions: keeping vent alignment steady, keeping internal components oriented relative to the Sun, or preparing for a maneuver that requires precise rotation. If Atlas is stabilizing itself intentionally, then the rotation is not a side effect. It is part of a controlled sequence, and sequences imply a plan. That plan becomes more visible when we examine the synchronization between venting and brightness cycles. The jets and the light curve do not simply correlate, they reinforce each other. As one becomes more defined, so does the other. This suggests that the system is tuning itself. In a machine, this would be a calibration loop. In a biological entity, it would be a regulatory cycle. In a comet, it should not exist. The shape of the cycles also matters. They are regular, but not perfectly uniform. The slight variations are informative. They hint at internal adjustments, corrections to maintain equilibrium as external conditions shift. These tiny corrections are too subtle for natural chaotic processes. They fall into a range that suggests feedback. Feedback is the hallmark of controlled systems. We must also acknowledge the implication of feedback-driven adaptation. Atlas may be in the process of awakening, reactivating, or preparing for a functional phase that occurs only near stars. It may have been dormant for most of its interstellar journey, preserving resources until it encountered a sufficient energy source. The Sun provides that source. If this interpretation is even partially correct, then what we are seeing now is only the preliminary activation phase. The main phase, whatever it is, has not yet begun. The fear deepens when we consider the ship's mass retention. Despite clear signs of outgassing, Atlas is not losing mass in the quantities expected. A typical comet's visible activity corresponds to measurable mass reduction. Atlas's activity does not. This implies that what appears to be venting may not be mass loss in the conventional sense. It may be a redirection of material already in circulation. It may be a thermal exchange, it may be a form of propulsion, or it may be a method of clearing accumulated contaminants from intake structures. Any of these possibilities removes Atlas from the natural category entirely. Another troubling observation comes from how Atlas interacts with solar wind. Natural comets show fluctuating tails that respond chaotically to variations in charged particles. Atlas's tail, if it can be called one, acts differently. It forms and shifts, but not in the expected reactive way. It seems to maintain structure against fluctuations, as if internal processes compensate for external changes. This would be comparable to a ship adjusting its shielding. No natural comet adjusts shielding. The more we examine the data, the more Atlas behaves like a vessel performing controlled environmental interaction. The venting resembles regulated exhaust. The rotation resembles stabilization. The brightness resembles energy cycling. The sealed structure resembles protective shielding. The activation profile resembles a system entering operational mode. All of these elements point toward one conclusion. The object becomes increasingly functional as it approaches the Sun. A normal comet would crumble. Atlas prepares. A normal comet would reveal its weaknesses. Atlas hides them. A normal comet would fail under rising thermal stress. Atlas thrives in it. The behavioral direction indicates that the object's most important phase will occur closer to perihelion, where solar energy is highest. This is why the scientific community's concern shifts from curiosity to anticipation. We are not waiting to see a comet burn out. We are waiting to see a system complete its activation. And we do not know what activation means in this context. This uncertainty would be tolerable if Atlas were a local anomaly, but it is interstellar. That means wherever it came from, environments exist where such systems can form, travel, and operate. The existence of one raises the question of how many more exist. If Atlas is a probe or vessel, then it may not be unique. It may be one of many, possibly one of countless. If Atlas is natural but highly organized, then nature produces structures far beyond our current classification. If Atlas is artificial, then we are witnessing interstellar technology operating within our system. Both possibilities carry consequences on a cosmic scale. Another fear derives from the object's silence. It has no detectable communication or broadcast signatures, nothing we can interpret as signaling. But silence is not safety. A dormant system makes no announcements. A probe executing a predetermined sequence transmits nothing. Some machines operate silently by design, especially if their creators assume no need for interaction with external observers. Atlas offers no explanation. It simply performs. As it performs, its behavior grows more coherent. Each new dataset reinforces the same profile: controlled, stable, purposeful. This consistency is not accidental. It implies that the object's internal condition is improving. It is becoming what it was meant to become in the presence of a star. Every sign points toward escalation, and the closer Atlas comes, the less time we have before escalation becomes revelation. As Atlas travels deeper into the inner solar system, one more feature becomes impossible to ignore: its energy balance. Natural comets absorb solar heat and radiate it away inefficiently. Their surfaces warm unevenly, their interiors lag behind, and the mismatch between internal and external temperatures produces stress that tears them apart. But Atlas does not exhibit this imbalance. The thermal readings suggest a surprising uniformity, as though the object is distributing heat internally with precision. This implies a mechanism, either physical or engineered, that ensures the ship never overheats in one location while cooling in another. Uniform heat distribution is not a trivial trait. It is a survival strategy. If Atlas was simply an exceptionally stable comet, we would still expect some areas to spike in temperature as it approaches the Sun. Those spikes would be visible as sudden brightness changes, as fractures, as deviations in outgassing. Instead, Atlas manages its energy load with consistency. This is the behavior of a system that understands its environment, not one that is destroyed by it. Even more alarming is the way Atlas modulates its activity depending on the Sun's angle of incidence. When sunlight strikes one hemisphere more strongly, the ship compensates. The jets shift output slightly, and the internal heating profile adjusts to keep the structure balanced. Natural comets do not compensate. They simply endure lopsided heating until they break. Atlas prevents the imbalance. This is the first clear evidence that Atlas may be performing environmental regulation as part of a larger operational cycle. When a system modifies its behavior to maintain optimal internal conditions, it is no longer a passive object. It is active. The next clue comes from the halo of particles surrounding Atlas. Although the coma expands, the density pattern remains surprisingly uniform in all directions relative to the jet axis. That should not be possible. A natural coma expands chaotically, shaped by gas eruptions, dust shedding, and solar wind pressure. Atlas's coma retains symmetry. This suggests that the particles are being emitted under controlled pressure. A consistent emission profile implies that Atlas is measuring its own output and maintaining it within a narrow range. When researchers examine the coma composition, they find unusual consistency. A natural comet should show shifting ratios as different layers sublimate. Atlas does not shift. The ratios remain stable, as though the ship is drawing material from a controlled source rather than the random layers of an ancient heterogeneous body. Everything Atlas releases looks processed. Another source of fear is how Atlas reacts to unpredictable external events. Solar wind shocks, coronal mass ejections, and localized magnetic field disturbances should produce chaotic changes in the coma and jets. These events routinely disrupt the behavior of normal comets, but Atlas reacts with minimal deviation. It absorbs external pressure and returns to its stable mode almost immediately, as if it has internal systems designed to negate environmental disturbances. If this is true, the object is not merely adaptive, it is defensive. A defensive interstellar ship is not a harmless object drifting through our system. It is a capable system with unknown thresholds and unknown triggers. When Atlas encounters brief increases in solar radiation, the result is not disorder, the result is refinement. The jets become narrower, the brightness stabilizes further, the rotation remains smooth. This is unprecedented. Natural bodies do not refine themselves under stress. Systems refine themselves under stress. Even if we try to avoid conclusions, the behavior forces us toward them. Atlas is demonstrating resilience, responsiveness, and precision. These are not properties of inert debris, these are properties of machinery. At this point, the scientific community starts focusing on the possibility that Atlas has multiple operational layers. The first layer may be passive traversal mode, the mode it maintained during its long interstellar journey. The second layer appears to activate when the object senses increasing stellar radiation. The third layer is likely still ahead, closer to perihelion, where solar input reaches maximum levels. This three-stage pattern is consistent with energy-dependent activation sequences found in technological systems. It also resembles biological organisms that awaken in stages as conditions become favourable. Yet Atlas does not resemble any known organism or any known natural structure. It is a cold, cohesive, silently adjusting body that behaves like an engineered craft. If Atlas is running an activation sequence, it raises urgent questions. What is the final mode? What is the purpose of the system? Does it execute a task near stars? Does it harvest energy? Does it transmit data? Does it deploy something? Does it react to gravitational fields in ways we have not observed yet? Without knowing the purpose, we cannot predict the consequences. The uncertainty is the danger. Even more unsettling is that Atlas remains entirely indifferent to our observation. It does not react to our attempts to study it. It does not change behaviour when telescopes focus on it. There is no indication that Atlas registers our presence or cares about it. A system that ignores external scrutiny is either unaware or unconcerned. Both possibilities carry risk. Unaware systems can collide or activate without considering local life. Unconcerned systems may operate according to logic that does not include us. The object's silence continues to be the most haunting quality. It does not broadcast. It does not signal. It does not alter course. It stays locked in its regulated, escalating cycle. For every piece of information we glean from it, Atlas provides none in return. The lack of communication would not be frightening if Atlas were behaving chaotically. Chaos suggests fragility. Chaos suggests failure. But order, increasing order, suggests the opposite. It suggests readiness. Another factor heightening concern is Atlas's interaction with gravity. As it approaches the Sun, the gravitational gradient sharpens, but the object's rotation remains stable. This stability under a tightening gravitational field is not typical of natural bodies. Stress should accelerate instability. Instead, Atlas keeps its orientation with precision. This orientation may serve a purpose. It could be aligning vents for thrust. It could be aligning internal components for energy capture. It could be performing a trajectory preparation for a maneuver that has not yet begun. If Atlas intends to alter its path, closer solar energy would provide the perfect environment for executing such a maneuver. That possibility forces the first tactical question: is Atlas planning to change direction? If it is, the activation sequence may not end at perihelion. It may peak there. And that peak, the moment of maximum energy and maximum internal readiness, may reveal the true nature of the ship. Everything we have seen so far suggests that what comes next will not resemble a natural comet's final disintegration. Instead, it may resemble a system reaching full capacity. We are watching a ship evolve into whatever it was designed to be near a star. We do not know whether that design includes interaction with planets. We do not know whether Earth is relevant to its mission. We do not know whether the object is benign, indifferent, or hazardous. But we do know one fact. Every hour that passes brings Atlas closer to its operational threshold. And once the system crosses that threshold, it will no longer be in a preparatory state, it will be in its intended state. We have never witnessed the intended state of an interstellar ship, but soon we will. As Atlas continues its inward approach, the most significant shift in scientific perspective emerges not from any single anomaly, but from the cumulative realization that every component of the ship's behavior contributes to a coherent operational profile, a profile that becomes clearer as the object enters regions of higher energy density. The data shows that Atlas is not simply resisting solar influence, but integrating it, shaping its internal processes around it, and using it to enter a more advanced functional state. This transformation is not the chaotic, destructive unraveling that defines natural comets. Instead, it resembles a calculated ascent into full capability, marked by increasing structural stability, refined emission patterns, and a sense of systemic alignment that suggests the object is not just enduring the solar environment, but preparing for something that requires the very conditions found near the Sun. This preparation is visible in the way Atlas rebalances its energy load, adapts its jet geometry with startling precision, and maintains a rotational consistency that should be impossible for an object of its presumed mass and age. Natural bodies show their flaws under heat. Atlas eliminates its flaws under heat. Natural bodies fracture. Atlas corrects. Natural bodies accelerate unpredictably. Atlas maintains exacting control. These observations do not merely hint at an operational motive, they outline a progression, a sequence, a staged metamorphosis that implies Atlas is moving toward a predetermined threshold, rather than stumbling blindly through its solar encounter. The most alarming development comes from the way Atlas increasingly behaves like a system optimizing resources in anticipation of a critical transition. The thermal analysis indicates not only uniform distribution, but also subtle temporal modulation, as though the ship is regulating internal temperature gradients to prepare for a high-power event. The consistent coma composition hints at the cycling of processed material, not random sublimation, suggesting an internal mechanism that selects specific compounds for release while retaining others. Meanwhile, the directional stability of the jets indicates the maintenance of thrust channels that could be used either for maneuvering or for sustaining internal equilibrium, depending on the ship's needs. Even the brightness cycles, once thought to be a simple rotational signature, now show secondary harmonics, minor fluctuations embedded within the primary rhythm that may represent internal diagnostic processes or energy routing functions. Natural comets do not route energy. Natural comets do not refine emission patterns. Natural comets do not prepare themselves systematically for transitions they have no capacity to understand. Atlas does all of this with a consistency that cannot be coincidental, a system that responds to its environment with coordinated, multi-layered regulation is not reacting, it is operating. As researchers dig deeper into the timeline of Atlas's behaviour, an unsettling pattern emerges in the progression of its operational modes. Early observations show low-level regulation consistent with simple thermal stabilisation. Mid-range observations show enhanced structural integrity and organised jet activity. Recent observations reveal complex synchrony across multiple subsystems: thermal, rotational, emissive, and dynamic. The alignment of these subsystems suggests that the ship is entering the final preparatory stage before initiating a primary operational event. This stage is marked by increasing coherence across all observable parameters, as though Atlas is synchronizing every internal component for a coordinated action. The true nature of that action remains unknown, but the preparatory indicators resemble the startup patterns of engineered systems designed for high-energy deployment or reconfiguration. The possibility that Atlas may be nearing a point where its behavior shifts from regulated preparation into active function is now taken seriously by researchers, not because they seek dramatic conclusions, but because the objective data forces them to consider such transitions as plausible. If Atlas is preparing for an event, then the event will occur near perihelion, where solar power reaches its peak, and where the ship's internal systems appear to be converging toward full alignment. The trajectory analysis reinforces these fears. While Atlas has not yet altered its orbit in a meaningful way, subtle rotational adjustments and micro-corrections in its outflow indicate that it is maintaining a configuration designed to enable potential maneuvering at a later phase. Natural outgassing would cause random deviations. Atlas suppresses randomness. Natural objects do not hold themselves in optimal configurations for future action. Atlas does so with evident intent. This suggests that perihelion is not merely a destructive endpoint or a passive turning point in its trajectory. It may be the activation site. Solar proximity could be required for a system designed to utilize intense radiation, gravitational gradients, or magnetic conditions. A ship engineered for interstellar traversal might require stellar access periodically, not as threat but as fuel, calibration, or initiation of long-range communication or deployment. If this is correct, then the behaviour we see now is only the prelude to a far more consequential emergence. This leads to a scientific dilemma that grows heavier as the data accumulates. If Atlas is preparing for full activation, what does activation entail and how does it intersect with the presence of planets, habitability zones, or electromagnetic environments like Earth's? We cannot assume that the activation is harmful, but we also cannot assume that it is neutral. A system designed for interstellar function may carry protocols that are entirely indifferent to the safety of biological life. It may generate fields, emissions, or dynamic forces that could disrupt satellites, atmospheres, or magnetic shields. It may deploy smaller constructs, release data, or draw energy in ways that we cannot predict. The absence of communicative behaviour only heightens the tension. If Atlas is silent because communication is unnecessary for its mission, then our attempts to interpret its intent will always lag behind its actions. If Atlas is silent because the mission does not involve interaction with us, then our presence is irrelevant to its planning. That irrelevance is itself a threat. Even more unsettling is the idea that Atlas may not be unique. Its arrival could imply that interstellar space is not empty, but populated by systems built to traverse vast distances, reawaken near stars, and execute tasks beyond our understanding. If Atlas is one ship executing an independent mission, others may exist on similar trajectories, separated by distances too great for us to detect, until they cross into our observational range. If Atlas is part of a network, then its activation may trigger or synchronize with actions occurring elsewhere. Every observation we make reflects only a single instance of behavior, not the full architecture of whatever cosmic system Atlas belongs to. The implications extend far beyond our solar system. They touch on the possibility that humanity's technological era is emerging in a universe already inhabited by long-range, energy-adaptive systems that move between stars with resilience that dwarfs our capabilities. As the ship continues toward perihelion, the situation reaches a point where every new measurement confirms the same conclusion. Atlas is not degrading. It is not weakening. It is not losing coherence. The opposite is happening. The object is approaching a state of maximum readiness, a condition in which all observed subsystems appear synchronized and optimized. The closer it gets to the Sun, the more its behavior resembles a system crossing a threshold, moving from passive traversal mode into active operational state. The jet patterns sharpen into narrow regulated streams. The brightness variations lock into near-perfect periodicity. The rotational stability surpasses that of any comparable natural object. The coma composition remains consistent despite rising thermal stress, indicating internal storage and release mechanisms not governed by random sublimation. The thermal signature shows controlled dissipation rather than escalating hotspots. These characteristics together point to a system poised on the edge of transformation. What comes after that edge is unknown, and the unknown is the true source of fear. If Atlas is a vessel, then perihelion may be its ignition point. If Atlas is a probe, perihelion may be its transmission event. If Atlas is a dormant artifact, perihelion may be its awakening. In every scenario, the moment of highest solar input is the moment of highest consequence. As the ship enters that zone, humanity finds itself observing the final seconds before an interstellar system performs the action it was built for, an action that we cannot predict, cannot influence, and cannot prepare for. Our entire understanding of planetary safety has been constructed on the assumption that nothing with operational capability enters our system from the void. Atlas has already proven that assumption false, and as the Sun's energy floods the ship's systems and the object nears its moment of full activation, one truth becomes impossible to ignore. Whatever Atlas is, whatever purpose it serves, whatever outcome its presence will bring, that outcome is no longer hypothetical, it is imminent. As Atlas enters the region where solar radiation intensifies beyond anything encountered during its interstellar transit, the object exhibits a new and deeply troubling behavioral shift. It begins to synchronize its internal systems with the external environment in a way that suggests deliberate adaptation rather than incidental response. The thermal output stabilizes into a consistent plateau. The jet emissions lock into an even narrower alignment relative to the solar vector, and the rotational corrections become so precise that they resemble active attitude control, not passive stabilization. The coherence across these parameters indicates that Atlas is now operating in a mode optimized for high energy conditions, a mode that was not active in the outer regions of the solar system. This transition confirms that the ship's earlier stages of behavior were preparatory rather than final. The stabilization we initially interpreted as resilience was, in hindsight, the foundation for a more advanced operational state that requires sustained solar exposure to function fully. The ship is not merely surviving perihelion conditions, it is adapting to them with increasing competence, as if these conditions were expected, required, and integral to the purpose of its journey. This shift becomes clearer when analysing the timing and magnitude of the object's internal adjustments. The energy distribution across the surface, once merely uniform, now fluctuates in cyclical patterns that appear correlated with synchronized venting and internal heat routing. These cycles grow shorter and more efficient as Atlas approaches maximum solar intensity, as though the internal components are accelerating toward a target operational speed. The behavior resembles a system attempting to reach a stable high-power state, the kind of state that only becomes possible when abundant energy is available. Natural bodies do not do this. They remain slaves to the limitations of their composition. Only engineered or adaptive systems display this type of staged activation, where each increase in external energy is met with a corresponding improvement in internally coordinated function. Atlas is not simply entering the high-energy region, it is using it. Simultaneously, researchers detect subtle but measurable changes in the object's mass distribution signature. Although Atlas continues to shed particles, the total mass remains anomalously stable, implying the presence of internal reservoirs or structure that compensate for external loss. The act of maintaining mass equilibrium under intense outgassing is far beyond the capability of any known natural comet. It would require internal control of density, pressure, or material allocation, processes that imply purposeful engineering or complex biological function. The fact that Atlas can regulate mass while simultaneously increasing systemic order and maintaining precise orientation suggests that whatever internal mechanisms it possesses are designed to operate specifically in this environment. This adds weight to the hypothesis that perihelion is not a hazard to Atlas, but a necessary phase of operation, possibly used to reset systems, recharge, calibrate or activate functions dormant during interstellar travel. The next alarming discovery involves the ship's electromagnetic signature. While Atlas does not broadcast communication signals, spectral analysis indicates intermittent fluctuations consistent with internal electrical activity. These fluctuations track with the thermal cycles and jet coordination, suggesting that Atlas has subsystems that rely on controlled electrical processes. Natural comets can produce transient electromagnetic noise when ionized particles interact with solar wind, but they do not produce synchronized electrical patterns that align with rotational states and thermal modulation. The consistency of these readings implies that Atlas has internal components that generate, route, or stabilize electrical currents, possibly as part of its energy regulation, or as a precursor to a more complex operational phase. If this is correct, then Atlas's silence is not inactivity, it is controlled internal function. These discoveries force the scientific community to confront a scenario they have resisted for as long as the data allowed. Atlas may be a functional object with discrete internal systems preparing for coordinated activation at perihelion. This does not automatically confirm the presence of intelligence, but it does confirm capability. The object behaves like a ship with engineered components capable of handling extreme environments, drawing energy from a star and maintaining coherence under conditions that destroy natural bodies. The implication is clear. If Atlas is a vessel, perihelion is not its end, it is its beginning. The trajectory data offers further cause for concern. As Atlas approaches the region where gravitational forces intensify sharply, the ship's orientation remains unnaturally stable, implying active compensation for gravitational torque. The stability is precise enough that small deviations appear only momentarily before being corrected, which suggests real-time monitoring and adjustment. This capability is not trivial. It indicates that Atlas can sense and react to environmental forces, and that its operational mode incorporates gravitational fields into its function. Natural bodies react blindly to gravity. Atlas integrates it. One particularly troubling model proposes that Atlas may use perihelion conditions to initiate a maneuver, leveraging gravitational and radiative forces to alter trajectory. If so, its current path may not indicate its final course. Once fully activated, Atlas could accelerate, decelerate, reorient, or execute a trajectory change that positions it for a new mission phase. Perihelion is the perfect environment for such a maneuver due to the abundance of usable energy and the steep gradient of gravitational force. While there is currently no direct evidence of trajectory alteration, the operational readiness that Atlas displays suggests that such a maneuver is within its capability. The possibility that it may choose, or automatically initiate, a new direction raises serious questions about whether Earth or other planets could become relevant to its mission profile. More disturbing is the lack of any recognizable pattern that corresponds to known propulsion or navigation systems. The jets, though directional, do not conform to typical engine exhaust profiles. They appear more like a hybrid between thermal regulation and controlled thrust. The brightness cycles, though stable, do not resemble communication signals. They resemble internal system synchronization. The electromagnetic fluctuations, though real, do not match any broadcasting technique used by known technologies. Atlas is not behaving like a spacecraft we would build. It is behaving like a spacecraft built with principles we do not yet understand. This gap in understanding compounds the threat. Without knowing how Atlas operates, we cannot predict what it will do next. Without understanding its energy systems, we cannot anticipate their impact on the surrounding environment. Without insight into its internal architecture, we cannot determine whether its activation poses direct or indirect hazards. The fact that Atlas is silent, precise, resilient, and accelerating toward full capacity makes the situation unprecedented. We're not observing a malfunctioning relic. We're observing a system succeeding at its intended function. These findings also challenge the assumption that Earth is irrelevant to the ship's mission. A vessel designed to operate near stars may collect data, deploy probes, adjust trajectory based on planetary arrangement, or execute processes influenced by electromagnetic fields generated by planets. Earth possesses notable electromagnetic signatures, an atmosphere with definable spectral lines, and technological activity that emits detectable patterns across space. Whether Atlas recognizes or cares about these signatures is unknown, but if its mission includes environmental analysis, cataloging, or interaction, Earth may become a point of interest simply because it fits criteria relevant to whatever Atlas is designed to do. As Atlas nears perihelion, the ship's behavior is reaching a level of coherence that no natural object has ever displayed, and the implications of this coherence become more alarming with every hour. The evidence suggests that the ship is not deteriorating, but evolving, not reacting but preparing, not drifting but advancing toward a state for which interstellar travel, energy accumulation, and environmental calibration were only the preliminary phases. The transformation underway is not random. It is structured, it is purposeful, and the window between preparation and activation is closing. The world now watches an object whose next phase may redefine humanity's understanding of interstellar systems, technology, and cosmic presence. Atlas is approaching the moment for which its entire journey appears to have been designed. When the ship crosses the operational threshold at perihelion, it will reveal the intention encoded into its structure and behavior. Whether that intention is observational, inert, or catastrophic is unknown. The only certainty is that the ship is ready, and readiness means that the most consequential moment of its existence and of our observation is imminent. As Atlas advances into the final segment of its inward trajectory, the ship begins exhibiting a new consolidation of behavior that indicates it is nearing the point at which its operational systems converge into a single unified mode. And this shift is so structurally coherent that even the most conservative researchers now accept that Atlas is not in a state of deterioration, but in a state of deliberate escalation, using every increase in solar energy as a catalyst for refining the efficiency and precision of its functions. This escalation becomes visible not only through the sharpening of jet alignment and the stabilization of rotational geometry, but also through a newly detected pattern of internal modulation that suggests the ship is coordinating subsystems previously operating independently, integrating thermal control, electromagnetic fluctuation, structural reinforcement, and mass distribution into a synchronized framework that appears designed to prepare the ship for a transition that cannot be explained by any natural cometry model. The data shows that as the ship absorbs more energy, its internal electrical activity intensifies while simultaneously becoming more stable, a sign that the ship is routing power with increasing sophistication, likely distributing it across internal components in preparation for an event that requires full system readiness. The thermal cycles tighten into near-perfect periodicity. The velocity of vented material becomes more consistent, and the coma density maintains equilibrium even under fluctuating solar wind pressure. A combination that demonstrates not only resilience but control. Control that implies Atlas is now functioning as a single integrated organism or machine, rather than a structure composed of discrete parts reacting independently to external forces. The ship's electromagnetic field signature grows more ordered as well, shifting from irregular background fluctuations into a defined pattern of timed pulses correlated with the ship's rotational phase, a correlation that suggests Atlas is using its rotation as part of an internal timing mechanism, possibly to synchronize processes such as energy storage, pressure regulation, or system alignment in anticipation of a full-power operational state. Natural bodies do not synchronize energy routing with rotation, nor do they generate repeatable electromagnetic pulses tied to thermodynamic cycles. This behavior belongs to systems that intentionally coordinate their internal timing, often as part of preparation for activation events that require precise sequencing. These patterns, when combined with Atlas's unwavering structural integrity, stable jet geometry, and continuous mass conservation, indicate that the ship is entering the final hours of preparatory function and accumulating the energy required to execute whatever primary operation it was designed to perform once it reaches maximum solar exposure. And as perihelion draws near, the uncertainty surrounding the nature of that operation becomes the central point of concern. Because a system that has demonstrated the ability to regulate itself across multiple environmental conditions, preserve its structure under extreme heating, and direct its own emissions with engineered precision is not limited to passive behaviors. Such a system may be capable of altering trajectory, initiating communication in a format beyond our detection, deploying smaller units, transforming its structure, or releasing high-energy outputs that could affect planetary or heliophysical conditions. And the inability to determine which of these possibilities aligns with Atlas's purpose leaves scientists facing a threat profile defined not by what the ship has done, but by what it is now prepared to do. The ship's silence continues to challenge interpretation, as it provides no signal of intent or mission, leaving all meaning to be derived solely from its behavior, and that behavior unmistakably points toward a threshold event, one that the ship's internal systems have been approaching with mechanical inevitability from the moment it entered the Sun's domain. The precision with which Atlas now regulates its heat load, maintains rotational stability, and channels vent emissions suggests a level of optimization that implies the ship expects, or requires, the precise environmental conditions that perihelion will provide. This expectation alone is alarming, because it demonstrates that Atlas's presence in the solar system is not incidental but purposeful, with its operational climax synchronized with the moment when solar energy density and gravitational gradient will be at their peak. The implications of this synchronization extend beyond Atlas itself, as they indicate that interstellar space is not a realm of inert wanderers, but a domain where systems can cross between stars with missions that depend on stellar proximity. Atlas may be one such system, and its imminent activation forces humanity to confront the reality that the universe may contain operational structures with capabilities and motives that do not align with human survival or comprehension. And as the ship nears the point where its systems appear fully aligned, where thermal, electromagnetic, structural, and dynamic signatures converge into a single, operational profile that has never been observed in any natural object, the scientific community prepares for the moment when Atlas will reveal the purpose of its design, a moment that is now unavoidable, imminent, and profoundly consequential. For once the ship reaches its activation threshold at perihelion, the solar system will no longer be observing a dormant or preparatory entity, but will instead be confronted with the true, fully realized state of an interstellar ship, and whatever that state entails will irreversibly expand or threaten humanity's place in the cosmic environment we once believed to be silent and safe. As Atlas enters the final and most intense region of solar influence, the convergence of its behavioral signatures reaches a level that can only be described as complete operational alignment, a condition in which every observable subsystem thermal modulation, electromagnetic activity, jet regulation, rotational stabilization, mass preservation, and coma uniformity functions as a coordinated whole rather than as a collection of responses to environmental stress, indicating that the ship has now achieved the internal state necessary to execute the purpose for which its entire passage through the solar system has been preparing it. The thermal readings show near perfect efficiency as incoming solar energy is redistributed across the surface in a manner consistent with a system designed to capture, store, or process high-energy input. While the jets refine further into narrow, consistent streams, that no natural sublimation model can reproduce, their directional stability suggesting they are now serving a dual role of maintaining orientation and possibly generating controlled thrust in anticipation of a maneuver, a possibility reinforced by the subtle but increasingly purposeful adjustments in rotation that appear to position the ship with mathematical precision relative to the Sun's gravitational and magnetic fields. At the same time, the electromagnetic signature of Atlas undergoes a profound shift, transitioning from intermittent pulses into a continuous patterned fluctuation that tracks with the ship's rotational period and heat cycles, creating a unified field behavior that resembles a system preparing to synchronize its internal components for high-output function. These fluctuations resemble neither random ionization events nor noise from thermal interactions, but instead form a structured waveform that remains stable through solar wind disruptions, which suggests that Atlas is either generating an internal electromagnetic lattice or preparing to initiate a process that requires field stability at a level natural objects cannot achieve. This stability is matched by an unprecedented coherence in coma composition. The emitted particles not only maintain uniformity, but now appear regulated by internal gating, as though the ship is selecting the precise type and quantity of material to release to maintain equilibrium during the final stage of activation, a behavior reminiscent of engineered coolant systems or pressure management protocols. The brightness cycles, once simply periodic, now exhibit secondary harmonics, merging into a unified rhythm that researchers believe may represent a complete synchronization of internal systems reaching operational lock, a state similar to machines achieving full calibration before initiating their primary function. It is this synchronization more than any single anomaly that indicates Atlas is no longer preparing, but transitioning into readiness, with all systems tuned to optimal values for whatever event occurs at perihelion. And the fact that this event requires maximum solar exposure implies that the ship's mission, whether technological, biological, or something entirely unfamiliar, depends on conditions present only in this narrow region of space. The growing consensus is that Atlas may be on the brink of initiating an energy-intensive action, such as structural reconfiguration, deployment of external components, long-range communication using solar amplification, acceleration via solar-assisted thrust, or activation of a system that interacts with heliophysical forces in ways that could have consequences for nearby planets. The possibility that the ship could alter its trajectory after activation is no longer theoretical. The precision of its rotational control, the efficiency of its thermal management, and the deliberate regulation of its jets collectively demonstrate the capacity for controlled movement, and perihelion provides the optimal environment for such maneuvering if the ship is designed to leverage gravitational or radiative forces. This realization forces another critical question: whether Atlas's path after activation will remain purely solar, or whether it may incorporate gravitational interactions with planets, including Earth, depending on the parameters of its mission. The silence of the ship, which once offered a thin reassurance that its behavior was mechanical rather than communicative, now becomes a deeper source of dread, because the absence of detectable intent, warning, or interaction suggests that whatever Atlas is designed to do, it does not require acknowledgement of other life forms or environmental constraints. It is a closed-loop system, focused entirely on its own operational sequence, unaffected by observation, and unconcerned with interpretation. The idea that the ship may have been dormant for thousands or millions of years during interstellar travel, only to reawaken fully within our solar system, reframes the scale of the threat. If Atlas is one example of such a system, then interstellar space may contain numerous dormant or automated constructs that activate when encountering stellar conditions, and humanity's ignorance of such systems does not protect it from their consequences. As the ship approaches its final few hours before perihelion, all evidence indicates that its internal state has reached total structural, electromagnetic, and thermal coherence, a condition consistent with engineered systems achieving operational threshold, and this threshold implies that the next observable change will not be another incremental shift in behavior, but a decisive activation event that could alter the ship's form, function, or trajectory. The scientific community now agrees that the activation, whatever it entails, will reveal whether Atlas is a harmless artifact, a functional probe, a self-maintaining vessel, or a system whose purpose poses unknown risks to planetary bodies, electromagnetic infrastructure, or even biological ecosystems. Yet the data provides no guidance on which outcome is most likely. What is certain is that the ship is now fully prepared, and that the moment for which it has been aligning its system since entering the solar system is imminent, leaving humanity with the realization that the first direct evidence of interstellar technology, or an unprecedented natural phenomenon, will not come gradually or safely, but through the sudden and irreversible transition of a ship whose capabilities and intentions remain entirely beyond human understanding. A ship that is now seconds away from revealing the outcome encoded into its structure long before it ever reached our sun.